Assalamu alaikum. Bismillahirrahmanirrahim. University of the Punjab. Associate Degree in Arts, Science and BA BSc Part 2. Annual Exam 2020. Subject Physics 2. Paper A. Time 3 hours. Mark 75. Note: attempt any 5 questions selecting not more than 2 questions from each section. Section 1. Question number 1A. What is electric dipole? Derive the expression for the magnitude of electric field at any point due to dipole. B. Calculate the magnitude of electric field due to an electric dipole of dipole moment 3.56 multiplied 10 raised to the power minus 29 coulomb meter at a point 25.4 nanometer away along the bisector axis. C. Describe very briefly the two properties of electric field lines. Question number 2A. Derive the electric potential due to a uniform line of positive charge at a point, a distance, y from the rod on its perpendicular bisector. Also evaluate the potential if we are very far away from the rod. B. What must be the magnitude of an isolated positive point charge for the electric potential at 15 cm from the charge 2B plus 120 volt? Assume that V is equal to 0 at infinity. C. How can you ensure that the electric potential in a given region of space will have a constant value? Question number 3A. By applying Biot-Savart law, calculate the magnetic field at any point, due to current passing through straight wire segment of length L. B. A solenoid 1.33 meter long and 2.60 cm in diameter carries a current of 17.8 ampere. The magnetic field inside the solenoid is 22.4 millitesla. Find the number of turns of wire forming the solenoid. C. Discuss the similarities between Biot-Savart's law and Coulomb's law. Question number 4A. Define indicator. Derive the expression for the total magnetic energy in a current carrying indicator. B. A 92 millihenry toroidal indicator encloses a volume 0.022 millicube. If the energy density in the toroid is 71 joule over meter cube, calculate the current. C. The current in a solenoid is reversed. What changes does this make the magnetic field B and energy density mu B at various points along the solenoid axis? Page 1 of 2. Page turnover. Section 2. Question number 5A. Using Bohr's model of hydrogen atom, derive the expression for the quantum energies of stationary states of the hydrogen atom. B. Calculate the radius of ground state of hydrogen in Bohr's mechanical model of one electron atom. The values to be used: H is equal to 6.63 multiply by 10 raised to the power minus 34 joule second. E naught is equal to 8.85 multiplied by 10 exponent minus 12 farad per meter. E is equal to 1.60 multiplied by 10 raised to the power minus 19 coulomb. Meter is equal to 9.1 multiplied by 10 raised to the power minus 31 kilogram. C. Describe difference between principal quantum number and orbital quantum number. Question number 6A. Considering the single photon electron collision, derive the expression for the wavelength shift of the scattered photon. B. X-rays with lambda is equal to 100 picometer are scattered from the carbon target. The scattered radiation is viewed at 90 degree to the incident beam. What is Compton shift? C. Why do we not observe Compton effect with visible light? Question number 7A. What is natural radioactivity? Derive the formula for the determination of the age of the sample by using the product and original nuclei. B. In a sample of rock, the ratio of lead 206 to uranium 238 is found to 0.65. Show that the age of this rock is somewhat less than the maximum age of solar system. The half-life of uranium 238 is 4.5 multiplied by 10 raised to the power 9 year. C. What is the difference between elastic and inelastic scattering in nuclear reaction? Section 3. Question number 8A. Explain forward biased characteristics of p-n diode by schematic diagram and graph. How forward resistance of p-n diode is measured? Explain the effect of temperature on forward characteristics of p-n diode. B. Explain the operation of the bridge rectifier circuit. Give the answer by giving path of current in the bridge rectifier circuit. Question number 9A. Describe in detail the basic structure of a transistor. Give the Biasing rule of for normal operation of transistor. Draw the circuit diagrams for NPN and PNP transistor with proper biasing. B. Explain the input and output characteristics of NPN transistor in common emitter configuration. Question number 10A. What is oscillator? How a common emitter transistor can be used as an oscillator? Give answer by suitable schematic diagrams. B. What is Boolean equation? Define AND and OR logic gates with the assembles and truth tables. Why an AND gate is known as universal gate. Page 2 of 2. University of the Punjab Associate Degree in Arts, Science and BA BSc. Part 2 Annual Exam 2020 Practical. Subject Physics 2, Paper B. Time 3 hours, marks 25. Group 1. Note: mark at least 2 experiments. The examiner will allot you 1 experiment to perform out of your marked experiments. Write down brief theory and procedure. Question number 1. Set up a rejector circuit. Draw its frequency response curve and find the values of response, resonance frequency, bandwidth and quality factor. Question number 2. To calibrate a voltmeter by using a potentiometer. Question number 3. To determine E/m of an electron by deflection method. Question number 4. To study the variation of photoelectric current with the intensity of light. Question number 5. To draw characteristics curve of a semiconductor diode. Question number 6. Practical notebook and viva voce. University of the Punjab Associate Degree in Arts, Science and BA BSc. Part 2 Annual Exam 2020 Practical. Subject Physics 2, Paper B. Time 3 hours, marks 25. Group 5. Note: mark at least 2 experiments. The examiner will allot you 1 experiment to perform out of your marked experiments. Write down the brief theory and procedure. Question number 1. To study the conversion of a pointer galvanometer into a voltmeter. Question number 2. Set up a rejector circuit. Draw its frequency response curve and find the values of resonance frequency, bandwidth and quality factor. Question number 3. To comparison the capacitances of 2 capacitors by ballistic galvanometer. Question number 4. To study the characteristics curves of a Geiger-Müller G.M. tube. Question number 5. To determine the ionization potential of mercury. Question number 6. Practical notebook and vice versa.